So everything needs an agenda. And so hopefully there's a little bit of a story arc to this. This talk is designed for people to get up and running and writing their first plugin, but there's going to be some tips on how to debug, how to use some of the features of Drone, and then finally there's how we write plugins at Drone and some of the tips and tricks that we use. And I would be remiss without saying that whenever I say Drone plugins, what I mean is CIE plugins as well. So these plugins are compatible for both CIE on Harness and also Drone on Harness as well. So I'll give a brief overview of Drone just in case this is your first time seeing this. I'll give an overview of what a plugin is. We'll step through creating our first plugin, and then we'll do the advanced stuff. And I'll also have a list of links that I use for creating plugins. So I'll go through this quite quickly. Now, what is Drone? Drone is a continuous integration tool. So it is something that will take your software and it builds an artifact. And it's all about that process of taking your software and building an artifact that may be used later on for building another artifact, like a jar file or an application, or something that you would put into a CD pipeline where you're trying to distribute that application out to the world. There's lots of similar tools out there. Personally, I love Drone, and I don't think I'll use any other tool aside from that, but it's well loved by the community. It's well adopted. It's open source. You get to see what's happening with it. And there's a lot of big customers that we have that use it. So the next thing is, what exactly is a Drone build? On the right-hand side, you can see an example pipeline. It has two steps in it. The first step runs some commands on a Linux container, and then the second step is actually a plugin. And that plugin, all it does is download a file onto your workspace that you could maybe use in a further step. Drone has loads of features. It can do parallel builds. It can work on multiple OSs. It's really funky. It has all the features, all the bells and whistles that you need day to day to produce software. So that's enough of that. Now we'll talk about plugins. So what is a plugin? A plugin is really just taking what would normally be a few commands, a few steps that would be part of your build, and wrapping it up so you can distribute it and reuse it in other places. So that concept exists a lot in software. So rather than having your own little custom thing that only you use, creating a plugin means that you can share that code with other people, and then you can parameterize it so it can do different things as well. So the whole point of plugins are enabling you to share the hard work that you've put in to figure out and solve problems. So if you look on the right-hand side there, we have plugins for doing different things. So for example, you may want to have a Slack notification in your build, or you may want to build a Docker container, or you may want to push something to Artifactory, or it could be something as silly as I want my lights to flash off and on whenever my build completes. So there's lots of different things you can do with plugins, but the whole point is it is a small, self-contained unit that you can then share with other people, even if it's in your own organization or outside in the open source community. Bit of a spoiler here. This is a brief preview of what is going to be the new plugin website. I'm fully aware that our current plugin website needs a little bit of love, and it has been getting that love in the background. And so over the coming weeks, we're hoping to release this. It's going to have many more features. It will have improved documentation, so getting up to speed with a new plugin will be much easier. And it has a better search as well, and hopefully it'll just make day-to-day much easier for people looking for plugins. So this is going to be our story. How do we create a plugin? So the first part we're going to do is we're going to create a script. Then we're going to wrap that script into a Docker, into a Docker image. And then finally, we're going to put that image into into our drone pipeline. And in reality, all a plugin is a Docker container. So this is going to be our first plugin. So dependent on your levels of knowledge with the world, or if this is the first time you've ever looked at trying to create something with software, this is going to be our very first plugin. And on the right-hand side, you can see that it is a simple bash script, and it is only doing one thing. It's curling a URL. And what's really fancy about that URL is it is a weather website. And the really nice thing about this weather website is if you curl this weather website on the command line, it gives you pretty graphics in your terminal. So all our script is going to do is find out the weather in a particular city, and that variable that is wrapped in a $sign and curly brackets, that will be the variable we pass through. The nice thing about bash scripts are, like, it's really easy to write them, and generally most of the things that you will want to do with your build day to day, you're going to be running commands for, whether or not that's running Docker commands, if you're running stuff with Kubernetes, if you're running an Apache web server, or you run Selenium, like, it always comes down to you're going to be running a command on Linux or Windows or Mac OS. The other great thing is you probably already have scripts that do most of the work that you would want to put into a plugin. So this is where we're going to run our simple script. Hopefully, whenever I switch screens, you should be able to see my screen. So you may have noticed that I am not running a Mac, which is probably pretty strange for a developer. I run on Windows, but I also use WSL2, which means I can run Ubuntu in the background. So big shout out to Microsoft for making that happen. So I am going to run my first command, which is what we had in the script. I am curling this URL, and what it tells me is the weather in Belfast is currently sunny. It's giving me all of the temperatures in Celsius, so apologies to America. That's roughly about 65 degrees, I think, if my conversions work out. And I have a script, a simple script that we saw. And this script is enhanced because I actually run two commands. I run the env command, which prints out all of my environment variables. And then finally, I run the curl command. So let's see what happens whenever we run that command. Oops. Oopsie, I'm getting there. So I picked a random city, and for some reason my internet's being slow. So the script is run. These are my environment variables. All of these are very important. You can see my current old working directory, my username, and probably very important information. But the country, or the airport, BCH, is in Golden Valley County in North Dakota, and the weather is not as good as it is in Belfast. So we've learned a lot. This will become the basis of our first plugin. It's a simple script so far. So how do we get this script to work with drone? And there's a few scripting fundamentals that we care about. We need to pass through parameters. So those will be parameters that are passed from the build or through secrets in your build or through parameters. And we also can use environment variables, and those environment variables are passed from drone about the build. And then finally, what happens in the build, we are concerned about the exit status. So the exit status tells us whether or not the plugin passed or failed. So going into more detail, how we pass information from drone into our plugin is through settings. So this is a little bit of a drone pipeline here in the bottom left-hand corner, and you can see that there are settings and there's a variable called city. So plugin city is what we pass through to the script. So drone prefixes the word plugin onto any environment variables or any settings that are passed into your script. All of the environment variables that drone has for you enables you to do things inside of your plugin. So you can find out who was the author of that particular Git push, have any other steps in the build pipeline failed, what's the name of the repository, what stage are we on, what version of drone are we on, and you can use that kind of information to infer what you should do next. So if I was to write a notification plugin for the end of my builds, I can find out whether or not a build step has failed, so I can give a thumbs down. But if the build is passed and there's no failing steps, we can give her thumbs up. And the exit status tells drone what to do next. So if your plugin fails, you can then tell drone to stop the build and not go on any further, or you can always return with an exit 0, and that means your plugin always passes. There are instances where you want your plugin always to pass, and sometimes that's just if you're like maybe pushing some instrumentation out to another server, just saying how long your build takes, and you don't actually care or want it to affect your build status if you are unable to push like how long it took. So on our 3-step journey, the first step is writing a script. The next step is we need to wrap our script inside of a Docker container. And it took me a long time to figure out how simple Docker is, but all Docker is a way to run a single command. All Docker is meant to do is run a single process until it completes. And so what we're doing here in this Docker file is saying, I want you to run our script. Our script is called script.sh. That's all we wanted to do. The other 4 lines that we see here are just information about like what do we want our base image to be. So we're basing this off Alpine, which is like a CentOS derivative, I think. I don't think it's Ubuntu. But you don't really need to care about that too much. And then finally, we're going to test our plugin in real life with the Docker command. So we're on to our next bit. This is where we have a look at our command line. So we have our Docker file, which we just saw. We're going to use our script. And now we're going to build our Docker file. So I'm going to call our image TP-honey weather. And you can see here that it runs through almost instantaneous. This is one of the advantages of using containerized builds. Containers are massively fast. And if you do things right, you can have your build happen incredibly quickly. Now let's test out our newly created plugin. So you'll notice this theme of I'm always passing through our environment variable. So this -e says I want to pass through our environment variable, which would be a setting in our build, to our newly created container. So hopefully we'll find out what the weather is like in Portland, Oregon. And so the weather in Portland, Oregon is not as good as Belfast. I somehow don't think we're going to get to the end of this demo where the best weather is in Belfast. Otherwise, I'll have to leave. So what we've shown so far is we can write a script, we can wrap our script inside of a container, and we can run that container and still get the same output. So the next bit is, and the final part is, we want this container, or our now what we call a plugin, we want to run that with drone. And so this is maybe a little bit more technical. And what I'm showing here is ways to debug if your plugin doesn't do what you want it to do. So you can run drone builds locally in two ways. On the left-hand side, I show us using a Docker runner, and we can run our plugin directly against it using a simple build file. Or we can also use the drone CLI. Just as a heads up for people, if people do use the drone CLI, I recently added a new version of the exec command, which now more accurately reflects how we run Docker builds. So previously using drone exec would have used the old 0.8 style of running a containerized build. Drone exec 2 is slightly more different, and it's much more modern, and it handles more features. So if people could try that out, that would be fantastic. So how are we going to run our plugin? How are we going to run this container in a build? And this is our example drone build file. So we are once again going to have two steps. So our first step is going to use the Golang container, which you would download from Docker Hub. And we're going to run a simple command of go version. So hopefully we're running the latest. Then we're going to run our next step, which I've called weather. We're going to use our newly created container, TP Honey Weather. This little line is interesting because what it tells drone to do is just to use the container that was built locally. And finally, we're going to pass through some settings. So we're going to pass through a city of JFK. So we'll see if New York has a better weather than Belfast. And we've also turned on debug as well. So we can see what's happening inside the build. So let's run our new plugin. So the first thing that we're going to do is we're going to look at our drone build file again. And you can see that it's exactly the same that I had on the slide before. We're going to use this image, and actually we've changed what we're doing. We're going to test against LA. So one of the really neat things about drone runners is you can actually compile your build. Whenever I talk about compiling, my eyes normally gloss over, but what we're going to use the compiler for is to see what environment variables are going to be passed through to our plugin. This can be really, really useful if you're trying to debug your plugin and find out why your plugin isn't behaving the way you think it should. So I'm going to run my compile. So this incredibly long path here is really just, I have built my runner locally. I'm going to tell it to compile, and I want it to run against this file. And what this is going to do is it's going to spew out a huge amount of JSON, and it's practically unreadable, but to the expert eye, it will tell you exactly what's going to happen. So I'm going to scroll up to the top, and you will see that there are environment variables being set and all sorts of things that will be part of your build, but we're really not interested in that. We can see that this is our first step. But what I'm really interested in is the environment variables that we're going to pass through. So we can see that we're going to pass through the environment variable of plugin city of LAX through the drone. Most of the time, you will never have to care about that, but it's just worth noting of how you can actually introspect what is happening inside of a drone build whenever your plugin is not functioning. And then finally, what we're going to do is we're going to do a Docker exec. So this is us executing the build with debug. So you can see it's run the first step, and then it went really quickly. So our first step ran, and we found out our Golang version. So we're running 1.18. With our debug turned on, we can see that we're running our weather step, and you can see the environment variables that are being passed through to our plugin. And you can probably see the city being passed through there somewhere, but I am being blind just here. And then finally, you can see that we have actually executed our plugin, and we can see that it is currently sunny in LA, and it is much nicer than Belfast. So we should all move to LA. Just for completeness, I am going to show us using the drone command line, and it's pretty much exactly the same again. It just runs through the commands, it runs your build. So if you need to debug your plugin, you can either use the drone command line tool, or you can use the runner itself. So let's get back on our journey. So we've actually created a plugin that works. We can pass through environment variables to it, and it was all pretty simple. We created a bash script that was 2 lines of code. We created a Docker file, which is almost verbatim hello world. And then finally, we just executed our build file with the Docker runner or the Docker command line tool, and our new plugin works. So that's kind of boring. Let's see if we can make just even a simple bash script do something more. So this script here that we have a look at the environment variables that drone uses. So there's an environment variable called drone field steps. If that's empty, we can say our build is good and we're going to display the weather. If our build is bad, however, we're going to make a call to the GitHub API and we're going to create a brand new issue. And I think what I have to say is if you can write a bash script, then you can definitely create a plugin. And I've been on lots of different courses where you can go incredibly complex and have to write lots of code and learn lots of stuff. Creating a plugin in Drone is really quite simple. And if you can keep it simple, do that. It is definitely worth sticking by. So let's test out our more complex plugin. So the first thing we're going to do is I want to have a look at my new advanced Docker file. So I am going to use a different script, which we just saw. I am going to use a new build file. Well, actually, let's build it first. This is us building our new container. This is our new advanced container. Now we can look at our drone, our new advanced build, and we once again have 2 steps. The first step is called step 1, very intuitively. And it's going to run this command, which is an incredibly bad command that will fail. We're then going to run our super advanced step using our new plugin. And we always want to run it. So this is a little bit of drone foo that says, no matter what, I always want to run this step. This is really handy for notifications, or if you only want to run a step if a build fails or a previous step has failed. So what I'm going to do now is I'm going to run our build. So we're going to run Docker exec with our advanced build file and run it in debug mode. So let's have a look at what happened. So way at the top, oops, scroll too far. Step 1, we tried to execute this is a bad command, and our shell decided that was not a very good idea, and we returned with an exit code of 127. And then our next step actually ran. So this is running our advanced script. It displays a whole load of information here from GitHub. I didn't bother hiding that. It's just useful for debug. And it finally finished off. So what did that actually do? So hopefully, if I go to my issues for my repo and refresh, you'll see that we now have a new issue created, and it's a broken build, and it's now told us that this step has failed, and the step that failed was step 1. Like, this is obviously an arbitrary example, but if you can curl or hit an API endpoint, you can make plugins do some like really incredible, very, very smart things. So if you can script it, you can make it a plugin, and you can share that plugin with the rest of your team, the rest of the organization, the rest of your company, and maybe even with the open source community if you get enough traction. So let's get back on the journey. So if all you wanted to do was write a plugin, you can probably stop off here. You know, as long as you can write a script and wrap it in a container, that's probably enough. However, if you're wanting to do something that lasts a bit longer than a bash script, also something that maybe works on Windows or works on Mac, if you need something that works on different architectures, if you need something that's going to work in different OS environments, then I would thoroughly recommend using Go. So the rest of the drone project is written in Go. The drone server is written in Go. The plugins are written in Go. The runners are written in Go. So it was pretty obvious that any new plugins that we create, we use Go for. The other thing is writing a lot of this code starts to become incredibly repetitive. So we actually template a lot of our stuff. I'm going to show you the templates that we use. And basically it's a single command, and it will produce everything in a Git repo that you need for a plugin. The other thing that I would say is you need to treat your build as software. So it needs to be repeatable. It needs to have good design process around it. And I can't talk for everyone, but it's incredibly hard to test bash scripts. Using Go just makes your life that little bit easier. You can wrap in unit tests. It has a whole load of functionality that will make your life better and easier. It will handle HTTP requests for you. You can run your own web servers from it. It is very good, very lightweight, and it creates incredibly small binaries. So it's a really good place to be. So how do we do this? Like, we don't just open Vim and do vim main.go and write our plugin. We use a little tool called Boiler. There's lots of different tools for different languages for creating templates and creating repos and applications. This is a little Go one. You basically use go-get to grab the tool itself. And then really the important command is boiler template use drone plugin. And that's the basis of which we build all of our plugins. And so if you follow what we're doing, you probably won't go too far wrong in terms of building something that is sustainable and testable. And then finally, we're going to talk about once we have our Go project, how do we build it and test it in a similar way to what we did with the bash plugin. So there's going to be an awful lot of console here, so I'll step you through the different parts, and hopefully nothing breaks. So I am going to go back to my workspace, and I am going to run our boiler command. So I want to create a little plugin, and I'm going to call it Bilbo. I don't know why, but it will do. And the nice thing about Boiler is it will ask you a series of questions, and it will fill out all of the information that you need for your plugin. So what will be the name of your container? What is the name of your GitHub organization? And you type all of this in, and it fills out all of that in the repository for you. But I don't care for now, so I'm just going to go for all the defaults. And you can see here that it creates a drone build file, because we need to build our plugin and be able to push it up onto the internet, on the Docker Hub. So all of that infrastructure is there. We have some basics for our git ignore. We automatically put in your license file. We have all of the Docker files necessary to wrap your new plugin. We also have the necessary Go files. We have this file, which is our plugin.go, which is where we're going to put most of our code. And finally, we have our build scripts that are used by our drone YAML file if we were to build and release this. So let's go into Buildboat, and you can see here all the files that have been created. We also put in scene stuff for the README file. So we put in basic documentation of how you would use the plugin. This is just really handy just to get started to know what kind of information other people will need to use your plugin. We can have a look at the code that it generates, and it's a basic template. There's not much to see here except for the fact that these will be the plugins, the plugin variables that you can pass through. And this is where we're going to write our code, literally write code here. So I'm going to cheat and I'm going to copy some code in to our plugin, but we'll have a look at it before it runs. And I haven't done anything special here apart from add a little library, and we're going to print out whatever parameter we pass through to our plugin. I don't think I have enough time to teach everyone Go, but this is fairly rudimentary. This is equivalent to a hello world. Like this is system.out.println we're doing here, or printf or println in C. And what we have to do first is we are going to do a little bit of Go stuff. You have to do this anyway. Basically, we're getting our dependencies. We're now going to build it. And if I do an ls here, we can see that we have actually created my badly named plugin called name. And what I can now do is, if I was to run this little Go binary, so whenever I run Go build, it's going to build it for whatever architecture I'm on. So it's built this little binary that will run on Linux, and I'm going to attempt to run it. And you can see that this parameter that I pass through to this little binary file gets outputted. The neat thing is that once we have this little bit of infrastructure in place, we can use all of the things that are inside of our scripts here. So you can see here that we're doing a simple Go build. It's really dull and boring, but you can see that we're building for different infrastructures and architectures, and you get all this for free by using our templates. So it builds for ARM64, ARM32-bit, ARM64. You can extend that out to do Windows, as you can see at the bottom. And if you're really fancy, you can extend it out to run on things like Darwin 64-bit, which is the new Mac OS M1 architecture. So we've shown so far, and hopefully everything, and I'm going to wrap up here, how that you can write a simple script, wrap it in a Docker image, run that as part of a Docker build or part of a drone build. And then we've also shown slightly more complex things, like if you actually wanted to write bulletproof code, you can use our existing boiler templates to create a Go project that does absolutely everything for you. And you just need to drop in some like 20 or 30 lines of code. And in fact, I really should show you exactly how simple it is. That we released a new plugin a couple of months back, the Git Leaks plugin. And I'm going to do a tree again. And it pretty much is exactly the same. You can see that I've built the plugin a few times, but whenever I look at our plugin code, you can see that the structure is the same. We pass through environment variables, our plugin paths, our plugin parameters, and then you can see what actually happens with the command line. And all this plugin does is really run the git leaks command. And it prints output to the command line, but it also uses adaptive cards as well. So that's the new visualization that you will see in your drone build. So the boiler template that we use currently also has adaptive cards built into it. So if you're interested in looking or authoring or adding in adaptive cards to any of your existing plugins, the boiler template's a really good place to look. So where do I go for information about builds? Here's all the links that I have. I will share the screen deck with you guys later as well. And I know that the video will be available after this call. So that's the end of my talk. Hopefully I've given some tips for people trying to write their first plugin, and also for existing authors learning how to debug, learning how to put in things like adaptive cards. So I'll hand it over to you, Dave.
Hey, great. I really enjoyed this talk. Is so full of details. I can't wait to share this with folks. We do have a couple questions, but folks, if you want to ask a question, go ahead and either unmute yourself or just put it in the chat window here. So one of the questions already answered by Jim. Thanks, Jim. But he's asking about the changelog going back between versions 0.x, 1.x, 2.x, etc. And Jim answered that there is a link. You can see it in the chat window there, folks, that the changelog goes back to 1.0.1. So that should give you most of what you need. If you need anything before that, I'm not sure what the answer is, but that goes back a ways. So
a really interesting thing is we use a container actually called changelog generator, and there's a plugin out there for it, and you can point that at your repository and it automatically generates your changelog for you. So if you have a look in the drone CLI repository or the drone server repository, there will be another file there called history.md, which contains all the previous commits. So everything in changelog is actually auto-generated every single time. But if you want to look at historical release information, it will be in history.md.
Nice. That's a cool tool. Good to know about. All right. And we've got another question here, really more of a comment. It would be nice to see new features documented at the docs.drone.io. And I'm suspecting that Andre might be talking about the adaptive cards, perhaps. Any word on when we'll get that updated?
Hey, that was me asking the question.
Yeah, good to see you.
Yeah. Thanks a lot for the presentation, and I would also like to share a feedback regarding the documentation. It really feels a little bit not broad enough. Like a lot of features and things are really not being obvious. Like recently, I was just looking for a simple thing like how to disable a step, because I wanted to disable it just temporarily. And I think I've seen somewhere how to do that, but I couldn't find that in the documentation. And there is a lot of like these sort of blind spots there. And so this comment is more of a like rather generic, that it would be really cool to have better documentation on the product. And one other thing I would like you to go into more details is the distribution of the plugins. Like, let's say I want to build a couple of plugins and use them across my organization. So how do I, where do I put them so that drone recognizes that, all right, this is a plugin, and I'm gonna work with that.
Yep. Okay, so I'll take the first point first. Adaptive cards, we have, the documentation is written and we need to distribute that with you. So that's hold our hands up. It has been altered, and we're going to share that. I suppose the way that I would describe the documentation that we have on docs.drone.io is it is documented, but it's almost like an index of information. It isn't really a guide. It's if you're looking for a piece of information and you know what you're looking for, you can find it, but it is not intuitive, and the search kind of sucks. And so we are looking into fixing that. The other thing that I would say is using Discourse as well is a good source of information of looking for workarounds or other pieces of information, like for how to disable steps, and that's very often what I end up doing. With like our recent hires with Marie and Jim, we want to change how our documentation currently exists, which is it's very prescriptive and it's very exact. What we want to start doing is giving more of the story, more use case things, whereby we can guide you through, like in a sensible, you start off here and you end up at the end of your journey where you have done something. And that's something that we will be adding over time. The other thing I would say as well is the plugin website currently, how the documentation exists for those plugins is it's free-form text. And with the new plugin website, we're going to have more structured input for the plugin website. So it means when you're moving from different plugins, you will have the same look and feel. It will feel more consistent, and it will be much easier to get up to speed with the plugin. So we are trying to improve on that. And the documentation thing, I have the same issue. So I fully understand what you're saying. If you know what you're looking for, you can find it, but sometimes it's hard to find the right search query to get that answer. And we will do our best to make that easier and searchable and more readable and more user prescriptive, rather than it being like API documentation, which is great for computers, but not so good for humans. In terms of the second question of distribution of plugins, that's a really easy one. Plugins are just Docker images. So it's really up to you which container repository you use. So if you feel comfortable posting your plugins to Docker Hub, you can do that. Or if you want to use Docker locally and sort of run your own container registry and point drone at that, you can do that. So it really all depends. So you could host your containers, your plugins, they're just a container. You could host them in Artifactory, or just with the Docker command line, you can actually host a repository locally as well.
Oh, okay, gotcha. So you can basically set up a drone server to look at private registry as well as the public one, right? Okay.
Exactly.
Okay, cool, thanks.